I want to make this video a little shorter than the last few. Just want to introduce three fundamental data types in Python: ints, floats, and bools. So to start out, let's define z to be 10 divided by 2. And I can ask true or false, is this equal to 5? And you do this the same way you would in MATLAB. You use two equal signs. So one equal sign is for assignment, assign z to have the value 10 divided by 2. And two equal signs is for true or false, are they equal? And so here, yes, I get true. And this true, that's an example of one of the two Boolean values, okay, the other one being false. And notice how it's written with a capital T. So if you spell it with a capital T, Python knows what that is. If you try it with a lowercase t, you get this error. And it's the same with false. They have to spell it with a capital F. And if you check what is the type of one of these, like what's the type of false, you get that this is a bool type. Okay, so let's use this z equals 5 somehow. So for example, we can make range 5, which I think of as producing the integers 0, 1, 2, 3, 4. Um, can try to do the same thing with z, but I get this error. And that is related to this difference between ints for integers and floats, which I think of as decimal numbers, something where it's not an exact integer necessarily. And the type error that we get here, that is telling us float object cannot be interpreted as an integer. So the only arguments we're allowed to put in to range, at least for these first three positions, are integers. So if I check what's the type of 5, that's an int. If I check what's the type of z, that's a float. And what's happening is when we do this 10 divided by 2, 10 and 2 are integers, but this fraction, even though 10 is perfectly divisible by 2, this fraction is getting turned into a float. So that's what's happening there, and that's the cause of this error. And in general, you have to be very careful with floating point numbers. For example, what should this value be? 0.1 plus 0.1 plus 0.1. Hey, what should that be? Yeah, it should be 0.3. So let's check. Is that equal to 0.3? And here we get false. And that sort of thing can happen in any context where you're using like not exact precision numbers like these floats here. So there's just some slight rounding error that's leading this left-hand side to get not recognized as equal to the right-hand side, even though we know mathematically that they're the same. Okay, I think that's where I'll stop this video. Thank you for watching.